and go to the Cosmos DB. Yeah, uh, cos just a moment. Hello, Cosmos DB. Cosmos DB is a global distributed database. It will support the multiple uh, APIs, and it is having the different features rather than SQL DB. This is mainly for the semi-structured data. Uh, uh, Earlier we supposed to use MongoDB and other NoSQLs. So we can use the Cosmos DB. A Cosmos DB is providing high responsive time, low latency, and high availability. And it is a completely serverless model. Of course, it is under preview. So serverless mode is under preview. Uh, it is supporting the enterprise level security and encrypted data at rest and encrypt in transit as well. And it is providing the automatic indexing. We no need to maintain the indexes. It will automatically apply the indexes. It consistent or manual. uh, there are two types. It will automatically apply the indexes on all the types, or is we need to in the manual we need to specify the indexes on the specific columns. uh, we can scale out, and it will support the availability regions and availability sets for high availability. uh, there are different, and there is a very good integration with the Azure functions. Whenever any entry in the Cosmos DB, Azure function will be fired. So this feature will be best suitable for the microservices uh, to to maintain the distributed transaction in microservices. We can commit the local transaction. Suppose we can commit the transaction in the local DB, then other function will be other Azure function will keep on monitoring SQL DB. So it will it, event will be fired and the Azure function will be executed, and it will call the subcode, and again it will be insert the data. So no need to maintain the queues. If you want, we can maintain the queues, but this is the durability purpose, but is a lot of integration with the Azure functions. During this feature will be quite useful in the microservice architecture. And one more thing, it will support the Cosmos DB multiple APIs, SQL core. By default, SQL core. If you want to specify it, you can select the Cassandra or MongoDB or Gremlin and a table API. Uh, the, uh, these are the APIs. We can choose one of the API while creating the Cosmos DB account. Uh, it will it will provide the integration with the cognitive set as well. Uh, but in this demo, we are not looking into the cognitive set, but in future we can see that one. Consistencies. There are a couple of there are 5 consistencies: a strong, bounded stainless, session, and consistent prefix and eventual. Actually, Cosmos DB is a multi model and a multi-master database. Multi-master is nothing but multiple regions allowed to write, not only one region, one region. We can allow users to write data or documents in multiple regions, either multiple regions or multiple data centers. Uh, not not data center, different replicas. Uh, uh, suppose two users are writing the same kind, are doing the same update, then we need to ensure the consistency. uh, Strong consistency, it means one replica is writing, other replicas are reading or writes. Suppose whenever uh, document is writing in one primary, other replicas will not be they will not see the data. This data will be until unless primary is committed, then only it will be visible to the all the uh, all other replicas, either write replica or read replica. Bound stainless, this is a strong consistency. This is the best for the consistency, but this will, there is a drawbacks with this one. We will lose the performance. It will apply the some kind of a locking mechanism. uh, uh, until unless primary is updated, the other replicas cannot see the data. But this will ensure that uh, only one master will be updated at once. And bound stainless, it will allow the some kind of a versioning. Primary is updating, it will secondary will be secondary, so two writes. So we can add, we can write data into the secondary, but with some stainless is nothing but some kind of a versioning, so additional versioning. So that is behind the actual primary document is different from the stainless document. So some kind of a lagging. And session, suppose one user, all the read and write operations are consistent, like is strong. But suppose other user, the write operation, whatever write operations is performing by other user, they cannot see. This is only applicable within the session, that all our read and write operations are consistent. The consistent prefix, the consistent prefix, they actually different order, read and write are sorry, writes and reads are different order, but uh, there is a sequence. Read all the reads, whatever order committed, same order we are seeing. So it's a suppose two commits are happened in the same way, we can see the same order, we can see that. So this is also providing some kind of consistency, eventual consistency. It will best for the performance, but it will not provide the strong consistency. Consistency will be less in this option. Multiple writes, multiple writes and reads immediately will be right. Suppose two primaries, two users are writing, two immediately it will be committed. But they, in other consistency, it won't commit immediately. One by one, based on the right replicas, it will be commit, and based on the consistency type. But in this, eventually consistency level, uh, whatever write operations performed to on any replicas, it will be performed, it will apply immediately. Then eventually asynchronously that changes will be synced with the other replicas, either read replicas or other replicas. So one document updated in one region, other document is updated in other region. Two documents, two NoSQL documents will be sync eventually. So one say, so some change happened in the replica one, write replica one, some change happened in the write replica two, and read replicas, they cannot see these two changes, but they can see one by one. Eventually, whenever transaction will be committed asynchronously, one event will be happened, it triggered, then sync will be happened between the primary and secondary, then eventually the data will be synced. So performance wise, this is the best approach. This level is very good for performance. But if you want the strong consistency like a SQL Server or all structured databases, this is the best approach, strong consistency. But this will give the low performance. The user cannot see the data until primaries are updated, completely updated. Okay, this is the one of the option, and now we can see a pricing model. What are the pricing model available in Cosmos DB? And Cosmos DB is in Cosmos DB we can measure the units in a request unit. In a SQL database, we can measure the units in DTU, database transaction unit. And here we are measuring the uh, pricing will be measured in terms of request unit, that is billed per hour, and storage and also storage billed in GB by SSD. It will be data will be stored in the solid state disk uh, for a high performance. Two copies, two backups are free. Additional copies are charged in a GB of data stored. There are two types of pricing model. One is provisioned throughput uh, and serverless. Serverless is still under preview. And provisioned throughput, there is two options. Standard in this option, in this pricing model, we need to specify how many request units upfront. Whenever we are provisioning resources, Cosmos DB resources, we need to specify how many request units we are going to use or we need. So in this standard uh, uh, pricing model, standard provisioning throughput pricing model, minimum 400 request unit per second, and it is good for the critical workloads, large applications. SLA is, if you see, 6 nines, very outage is very. We can see that how triple lens is a kind of a minutes. It's a low. It will provide the low latency, high availability. It's best for the all the critical workloads. And there is auto scale also. We can start with the minimum request unit. Then we can based on the usage, we can increase the our request units capacity for the for our workloads. Instead of provisioning upfront, we can we can start with a minimum thing, and we can slowly increase based on the usage. This is this will support 400 request units per second. And serverless. Serverless is eliminates the war provisioning. It's no need to provision how many request units upfront, but we can create the account and we can start using base, and this is the one of the cost effective option. And there is a there are two more options. Reserved capacity. Last time I showed for a SQL server how to reserve the instances, the SQL DB instances, SQL DB managed instance, or SQL DB. So we can achieve 65% billing cost with the reserved capacity. I can show you the uh, pricing in the Microsoft site now. Suppose if you the total cost of ownership like serverless, it's a 70% billing cost. Okay, just a moment. I'm opening this one. This is the Microsoft site. It will support all these regions, and it will currency we can calculate any in any currency, and it will be displayed in the month. So suppose maybe US dollars is to S. Suppose single region, it's not a availability set or availability region. Single region 100 auto scale request units per second, write a account, it's a $8 per month. And this is availability zone. Suppose a single region, within the region availability zone 100 request units is a, this is the it's a kind of a factor. This is the base price, and into the 1.25 factor, this is the total cost. So it's a kind of in the availability set, we have the two instances created the first two replicas is free, but first two replicas is free, and other same kind of replicas will be created in other data center also within the zone. Sorry, within the region, other zone we have other replicas will be created. So it is a base price into 1.25. This is the single region with the right account distributed across the n regions. So this is the availability zones, sorry, regions. So this is how many regions we are creating. So n, suppose we are managing two region, 4 into 8.76. So it's not that much costly one. If you and if you use the reserved capacity, we can see the calculator better. In this calculator we can see all the thing. Where is that? I think this is the both the same. I think. Yeah, I think I didn't copy. Just a moment. Yeah, this is a calculator. Suppose one region. One region supposed to, it depends upon the region, and multi-region is number of regions, and number of master nodes, and total data stored. How many? Suppose 10 GB or is a depends upon the storage plus the number of regions, and the number of request units per number of write operations, update operation, how many operations. So it will be calculated. Suppose one region maybe 1 GB. We are not seeing that much difference, so storage is not that much. Suppose 50 reads. Okay, suppose not this one. Enable calculate. Suppose multiple regions, 5, 6 regions. Okay. So this is the cost for storage, $15 per month. for 10 GB. And suppose request unit 100 request units. This is the cost. This is the request units, and through workload. Suppose number of regions 6 into uh, 6 into 98.41. So it will be this will be the cost for the 6 regions. Suppose if you are using the suppose if you are using the total cost of uh, T, ownership or reserve capacity is almost 70% will be reduced for TCO, and 65% will be reduced on $600. Suppose reserve instance. Suppose I'm going to create the go to the Cosmos reservations. Where is reservation? Yeah, Cosmos DB. Yeah, this is the monthly capacity for the 3 years, $219. But if I choose, it will be more. It will be increased up to 400 something. Uh, so we will get up to 65 to 75% the deduction or benefit if you reserve the instances up to 3 years, or if you create the total cost of ownership. That is also, it will give the uh, better uh, uh, price. Okay, now we are create the Cosmos DB. We'll switch to the presentation. Uh, there is a there is before going to create the Cosmos DB account, there are a couple of tools we need to discuss. Cosmos DB tools. In the Cosmos DB, we have the couple of tools and integration with some other IDEs. Cosmos DB emulator. Like a storage emulator, we have the emulator for the Cosmos DB service. During the development and test application locally, we can use the Cosmos DB service without any Azure subscription. It's completely in the local, like a storage emulator, uh, and it will support the Docker support as well. We can in the Docker in the virtual container also we can install the this tool. And this is open source, and no, no, it's not open source. It's provided by Microsoft. The Cosmos DB data migration is an open source project to migrate the documents from uh, local storage or storage account, Azure storage account, or local storage, or website, some website. We can move the files to the Cosmos DB, either emulator or Cosmos DB service account. It will connect, and we need to specify. We can see that in the demo. We can see that. And in the Cosmos DB emulator, we have the certain limitations. Actually, Cosmos DB, it will provide the distributed uh, across the multiple regions. And it will support the multi-model APIs. But a Cosmos DB emulator, it doesn't support as of now, it doesn't support all other APIs. Only it will support, as of now, it is supporting only SQL API client. And it is not supporting the multi-region or multi-region support or scaling more than 400. It is not supporting. This is just working with the local applications for development purpose or testing purpose. Instead of creating the Azure Cosmos DB account, for development purpose, we can use the Cosmos DB emulator. Uh, and a lot of integration with the Visual Studio Code and Visual Studio as well. We can see the demo how to install Cosmos DB. If you see, we can download the. This is the executable. We can download the executable. I download the executable from the Microsoft site, and I ran the emulator. This is the local emulator. This is the local emulator. Local Cosmos DB emulator. In this emulator, this is the service account. This is the primary key to connect to the Cosmos DB. This is the primary key, and this is the URI, and this is the connection string. Connection string is nothing but some combination of a URI, service account, is nothing but an endpoint, account endpoint, and key, account key. Okay. It is supporting only SQL API as of now. As a tool, we can create multiple databases. We can create first. We can create the account in emulator. Then we can create the account in Cosmos DB, and then we can create the one sample application how to connect to the Cosmos DB. Okay. I'm creating one database account in Cosmos DB emulator. Maybe test DB. This is provision throughput, standard provision throughput or auto scale. As explained, these are the two pricing, but this is just for the development purpose. This is not actual DB. Sorry. Okay. Created. Okay, the database is created. Now we can, if either we can scale or we can create the container. This is the just account, database account. We can create the container. Uh, okay, and partition key. I need to provide the partition key. I'm providing partition key. I have some some documents, JSON documents. Suppose in this one, just a moment, I'm downloading Cosmos. I'm Yeah, I need to specify the partition ID. Go to the okay. I will create again test DB. Okay. Uh, okay. Partition ID. This is the container. My partition is larger than 100%. No. So if you want, you can specify unique key. If you have any other ID, I'm not uh, creating. Okay. So this is the Cosmos DB account. This is the container. We can create the multiple containers, and suppose I want to upload I want to upload the existing documents. I can upload. I can upload that. Maybe if I can upload 5 documents, then we can. Oh, yeah, we can delete it. It's not a problem. Okay, these are the documents. I have sample JSON documents. Suppose 7 to 10 I uploaded. Okay, upload. It is going to upload the documents. Okay, I think it's already uploaded. uh, Refresh. Yeah, the this is the document. Easily we can upload, we can see the documents. This is the hierarchical uh, relational database. uh, so, so this is document, this is the one document, this is one document, this is a partition key. uh, this is the partition key. Where is that? This is a partition key, this is the ID. Okay, and now there is one more tool. This is we can do the some test. We can read the document, we can upload, we can update the document through the uh, through uh, uh, dotnet application. Can do that. And there is a other tool, uh, migration tool. I can open that one also. Just a moment. There is a migration tool. Downloaded the migration tool. Just I need to open. And uh, this is the tool. Yeah, this is the one. This is the data Cosmos DB migration tool. In the source, we can specify that we can add the files. There are multiple sources. As I told, we can select the desktop, uh, JSON, colleges. We can select the multiple data, multiple files. Easily we can select the multiple. Suppose if you don't know the files, you can select the folders. You can select the single folder. It will read all the files. Suppose if even you can if you know the URL, suppose your JSON document on a particular website, you can website or a link, you can upload the URL also. And there is a blob, and you can specify the storage account, uh, container URL or account key, and some kind of blob name. So the blob name or expression, maybe some kind of a regular expression. So it will find all the blobs and it will upload it. Suppose it means that if a document are to Azure storage account, we'll just specify the account key and the container URL. It will read and it will upload. So this is one option. And then next target, I need the connection string. Connection string. Go to the start. This is a connection string. This is my connection string. Go to the Explorer. Instead of uploading into the Azure account, I'm uploading into the emulator. Where is the yeah? This is a connection string. Verify. Database document name should be as part of the connection string. Okay. 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 Semicolon. Test collections. We need to, suppose in which container we need to upload. Suppose I have colleges. If you want to in the same database, in the same database account, if you want to upload into the multiple other container, we need to specify that container. College, and there is a primary key. Sorry, partition key. Partition key, college, and partition ID. Uh, this is the partition ID. Okay. Then next, I don't have any. I didn't specify any ID, but partition ID is fine. Next, uh, next, import. Earlier we have 7 to 8, 9, 10. So 4. Now it will upload here remaining things. It is uploading, transferring the data from. Uh, Instead of emulator, you can upload into the actual Cosmos DB account also. If you know the constant string, you can upload into the actual Cosmos DB. It will upload into the Cosmos DB. It will upload on the one. Okay, we'll come back this one to save the time. Go to the we can create the one Cosmos DB account in Azure. I already create. Let me see. I already created. Let me create one account. Cosmos did create. I will create Cosmos DB account. I already created. Okay. Okay, I will create again. No problem. Add. No. I will create the new account. It's completed. Okay. Go to the emulator. No, this is the pricing. Where is emulator? This is emulator. Okay. Yeah, it is uploaded all the documents. You can see, you can navigate. All the documents is uploaded. If you want to query, there is a couple of. This is a SQL API, so we don't have collections. This it is not supporting the MongoDB collections. Suppose where C C dot name name P Q. Maybe I can choose one. Okay, maybe QR 25. Apply filter. Yeah, it is selected. This is the name. If we can give the API select. Suppose ID get the type T, not this one. I name ID apply filter. Yeah, it is applied. This is 33. I think I we have only one item. Suppose 30. We have 4 items maybe. Yeah, it's a normal SQL query. No need to specify the container name or table name. This is not table. Actually, this is the collections or container. The main thing is this is supporting only SQL API. It's not supporting other APIs. This is one thing. What I want, yeah, I will create the Cosmos DB account. I will choose the uh, this one. Uh, HRTD. Maybe I will create new group. Uh, yes. is yeah. Mm, this is Azure TD. So by default core, uh, if you want to select the Cosmos DB for Mongo API, Cassandra, Azure table, Gremlin, or GraphDB, GraphDB, we can choose the one of the API model. It will support all these APIs, all these 5 APIs. Now I'm selecting core SQL, notebooks. This is under preview. Anyway, I don't need that option. Location, I'm choosing East US, and this is serverless. Serverless is still preview. Provisioned throughput. This is standard or some kind of uh, auto auto scale or auto standard or auto scale only a provision throughput, apply free time, yes, account type, non-production, yes, geo redundancy. I'm not creating the multiple replicas in geo redundancy, multiple region rights. This is not my master, and availability zones, but it is supporting all these features: geo redundancy, multiple replicas in multiple regions across the globe, and multiple rights as well. I'm not specifying. Oh, okay, maybe for demo purpose I can specify. But yeah, not availability zones. So I am review. And there is some other options. Network. Yeah, this is one of the restriction at network level. Of course, one of the security as well. It will allow all the networks or public endpoints or private endpoints. So it's, for public endpoints, maybe selected networks. Okay, this way. All the networks, it will allow all the networks. Uh, and the private endpoints, it will we need to specify the particular endpoint. Uh, so it's a kind of a some kind of a firewall configuration. Uh, I'm specifying on the network for demo. There is a backup policy and encryption. Suppose backup policy, suppose how many day, retention period interval, how much retention is 8 hours. Or if you want to change to 2 replicas, anyway, copies data retained, 2 copies will be retained. And encryption, server managed key or customer, you can bring the our own key to encrypt the URI, to encrypt the data, the data at rest. uh, okay, this is fine. Backup policy period, okay, this is fine. Okay, create. So it is going to create the uh, deployment across the still underlying might be helpful. At least one resource deployment to resource group fail. What is this? Yeah, I already created the free tier, so it is not allowing to create the another tier. That is the only, that is the reason. Okay, I will do the one thing. Uh, it's the same. I will do. I will delete the account and I will create again for demo. Uh, agent. it will take some time. Meanwhile, uh, I can prepare the some document, some project. I think it is completed. I think no, it is not completed. Okay, let it be. Meanwhile, okay, I can create the some data, some project. Data services, Cosmos. Yeah, a couple of things I am going to explain. There is some ARM templates. ARM templates also we can create the uh, we can create uh, resources from ARM template. We can create the resources from the CLI. I will show you how to. I will navigate. I will walk through what are the. Let's say okay. Uh, Here first we are creating the resource group. Maybe I can open it. Exist. Oh, God. Yeah. Yeah, we are creating the these are the variables. We can create the resource group by using the AZ group. Then we can create the account resource, just name and resource group. We can create the account, and we can see the constant string. What is the constant string? Then we can create the database in the Azure account, and we can see and Azure SQL. This is a SQL API for constant. I'm creating the database. If it is not exist, then only we can create the database. If it is not exist, we are creating the database using SQL data SQL API model. Then we can get the constant string by showing by using show word keyword, and then we can create. So database account is created here, and if the database is created, then container is we are going to create. In the container, we are specifying what is the partition key, what is the container name, resource name, database name, and account name, and this is the constant string for the container. Uh, that's it. No, it's not constant string. Just we are verification that container is created or not. This is the show key. Show means just we will get the output. It won't give the any constant string. Yeah, this is one thing. Then I'm closing this one. I will create the new project. Close folder. Then go to the uh, commander. Oh, my system is very slow. Oh, this was running. Okay. Um, Cosmos. Then uh, yeah, go to see. Then I will create an application for uh, console output demo. Oh, agent Cosmos. I can use the entity framework. Then uh, console app. Console app. It is going to create the one console application. Okay. Then I can close the existing one is to save some memory. I think it is completed. No? Yeah. Oh, it's very slow. Even I don't know why this much slow. Maybe my network is slow. It is not deleted yet. It is not deleted. Delete. Just delete again. This one is add. Yes. Oh, this is second one. Cosmos. Still deleting. Okay. Let it be. Good. It is deleting. It's not completed. I'm too fast. Okay. Let it be. Let it anyway. I will work with the local DB. Meanwhile. Okay. Uh, no, I don't want. I want this one. Open folder. Uh, Cosmos. Cosmos console app. Yeah, this is the one I want. Uh, okay. Now I'm going to add some packages like in the previous project, uh, previous demo, how I build the configuration. I build the configuration. I don't want to use the static one. I want to build the configuration. Uh, uh, Microsoft. Yes, just a moment. What is this? Okay, control. So dot. It will give the matching. How is possible? Yeah. EntityframeworkCore. First one successfully added. Okay. This is Cosmos DB Cosmos. Now I'm going to add a design design as well. Design. Okay. And now I'm going to add tools. Tools is not required anyway. Let me. Then I'm going to add the configuration stuff. Uh, con uh, Configuration 5.0. This is now extension dot hosting model hosting 5.0 uh, login. Yeah, fine. Then first I will create one application with normal one. Then I will create the sorry. First I will try to connect the Cosmos DB using the entity framework app config. Uh, in the previous module, I built some kind of a configuration settings. I can build the same thing, but this time I will not do everything. First, I will build the hosting builder. Then I will add the host configuration. Then I will configure the app configuration. Then I will configure the services. So three elements I need to build in the uh, hosting builder. So I will create them some class, sorry, some method. Uh, Public is even not required. Nobody is calling static host builder. Control Shift B. First, I will build the application. Okay. Now I will create the configuration. Configuration. And one more configuration. I will create the user secret config. Yes. Yeah. This is the user secret config. And now I will create the Cosmos DB settings. Application settings. This is config. This is Cosmos DB. Now I'm going to create the some settings. Same settings here also. Uh, same settings and security also we can use the same settings. But instead of this endpoint and database, I can use the local one. Suppose here I'm using the I don't know. This is the local emulator. This is a local DB. This is this is the service endpoint. Copy. Go to the project. This is the development purpose. I can use this one instead of my database. This is the one, and account key. I did the account key. This is the account key. Go to the. This is the account key. Account key. Account key. Then database. Database is college DB. That's fine. We are using college DB. College DB. Maybe correct. Yeah. And then collection container ID. Container ID. Colleges. This is the configuration I'm using. Maybe I can use the same thing for secrets as well. It's both are this is for development purpose. Okay. Anyway, whenever we are going to production, we will change the app settings for production settings. This is the one thing. Okay, configuration is ready. Now I need to build the builder. Okay, host builder. Starting a host builder. Uh, Copy from the previous module. Host builder. String array. I can use the lambda expression. Uh, host dot no, host dot host create. I think I am missing some kind of a namespaces. I'm going to add some namespaces. Created default builder. Parts. Then use environment. Create environment variable sp that core underscore environment. And this is one. No, actually this is not required, but I just am setting user. This is fine actually. This is fine, but I'm setting if it is not. It is not a default. Is now I'm configuring the host environment. Configure host environment. Uh, I, I can use the previous module. The host settings I need to create host settings. Then I need to add the app settings. App configure apps configure app configuration. Then there is a two parameters: host builder context and configure builder. Then I need to use the two from previous module instead of writing to save that sometime. This is the correct one. Yeah. And then I need to add the services, configure services. Uh, Instead of using, I can save some time. Yeah. Uh, this I think I will create this one. I will create this one. This is fine. Yeah. Uh, I can create the context and I can create the Cosmos DB settings. Yeah, this is the one. And then this is fine. Now I will create the this these are the these items uh, settings. I can create one folder. In this one, because to maintain the settings, I can create one class, two class. Okay, then I can use the I think settings. Yeah, settings fine. Uh, settings are config also fine. Um, then I will create some list of properties to read the configuration from the configuration file and to hold the data. So, this is just a settings name, to database ID and container ID, and I hold the data. And there is a I think all databases we are using the uh, I can create the another class class Cosmos DB settings. Cosmos DB settings. In this one, I will create the uh, two endpoint and account key, two properties to hold the data. Okay, now go to the program. We have the college Cosmos DB, but it is not inheriting. It is not a okay. It is not using some using what is it? Demo Azure Cosmos Entityframework dot Solab dot config. I think it will recognize. Still, it is not recognizing college Cosmos DB set dot settings. Yeah, this is a construct string. Uh, this is the set college Cosmos DB settings. This is the name, just name to read the configuration settings. That is correct. Anyway, this is Cosmos DB set Cosmos. No, I think we need to use this one. That is yes, wireless Cosmos DB settings. We need to use this is the one. Secrets programs. Now we have of course it is showing as error, but it's not error. These are the fine. But college context I can create. Before creating context, I need to create the entities as well. So I can create the one models. Uh, Instead of class, I can create the new class. Couple of classes I will add. College entity. Okay, college fine. And there is another class. College is having the departments and courses. So I will add departments. And college is having the address. Address. College is having departments. Department. So this is another class. Another entity. I will add one more courses. New class courses. Course. Now each one is having the each entity, each document is having the primary key. So I can create the some kind of a interface to restrict the keys, to restrict the IDs. So I can create the one interface. Uh, in this one, I can specify the type, generic type. It can be anything, integer or string. Now I can use ID. Uh, so this is the one, and then I can create the one more interface for partition. The interface partition ID, partition key, partition. That I can create the partition ID for this one. So this is the one. Okay, then we are good. So course here, go to the college. This is the primary document. This is a class. In this one, I will inherit the I key and a partition key. This is integer. This is I partition. Partition key. Now I'm going to implement. Oh, okay, it is throwing error, but okay, fine. Okay. This is fine. Now I'm going to create this. I can create the couple of properties to hold the data, name and all. Okay, I will quickly create. This is name. Name should be string, and this should be a register number. This should be number. Okay. Next one, partition ID I already created. So, but this is the partition ID should be. Uh, I can create some kind of a JSON property. JSON property. Property name. I think it is showing something. Okay. I think total software I need to use. Total soft. Okay. This is fine, and I'm using yeah, it is giving interesting. Okay, so now I can use the partition ID. This is JSON property. Property name equal to uh, established year. Established year. And okay, this is the one thing. What is this? Yeah, caps. Yeah, this is fine. Name and okay, register number and um, then address. I need to use the address. I think this is correct. Register number is integer. Then I can use the address for one more. That is fine. We are good for this one. I can override. Override string to string. Okay. Now what I'm going to override instead I can override to string return JSON convert dot serialize object. So it will serialize and it will give the string. I will give the this. So it will give the JSON string. Okay, this is the college entity. So college is having the one object that is one to one, one to one and a one to many. One more object, one more sub document or sub uh, collection. I think it is. I need to add a using system dot collections dot generic. Yeah. Then I collections, yeah, collection department, department, yeah, perfect, departments, get set. Okay. uh, Instead of none, this is new way of writing department. Yeah. Okay. So I, now I need to create the address and department and course. So now I will use the same kind of a thing. Load soft. Okay. Now public fine. Everything is fine. Properties. I will create a couple of properties. Okay. This one is an apartment name. Apartment. I think everything is straight. No, I think it is what I like. Okay. Apartment. Building number. Building number. State. City. City and state. Then country. Country. Zip code. No. Perfect. Now we are good. Address is created. College is one document and the course. Course also I can create the course few details instead of properties. Okay, couple of documents. Okay, uh, course name, street, course name, course duration, and course fees. Okay, this is fine. Maybe by default duration. Okay, course duration. This is fine. Departments. I think I need to create the department as well. Uh, we will create department property using system collection. Yes. Then properties. Okay, this is file ID. So this is department. This is department start date. Department name string. String department start date. Department end name. String department end name, and then number of in department. How many courses are there? Courses. Then this is one to many. My collection. Courses. So yes, course. Okay. Okay, this is not required. Okay. So we build the model, college model with the address, college, courses, department, some kind of keys and constant. Now I need to create the contest, college contest, college DB contest, or college contest. I am going to create the college contest, college DB contest, college DB contest. In this one, it's very easy, straightforward. I can create the constructor. Uh, Default constructor is fine. I know I need some kind of a constructor with a dependency injection, DB contest option. I think I need to first I need to use using system Microsoft framework for Microsoft extensions dependency to for dependency injection extension dependency injection. Okay, then DB options, DB context options. College DB contest. Oh, why it is not showing? Okay, options. Yeah, I think settings I need. College DB settings. Settings. Now I can use the base option. Okay, I think I need to use it. No, it is not showing. Okay, good. No problem. I can use manually. College DB setting. Using settings. Okay. Base options. Okay. This dot. I think it's slow. Meanwhile, I will check is complete or not. I will create the database. Just a moment. This is also slow. I don't know why machine is too much slow. Yeah, I need read-only property. Yeah, it will create. Yeah, this is fine settings. Okay, and then I can create the some kind of a DB sets. Set college, college. Then why colleges? Get then I need to override the on configuration function. Then override y on configure the on configuring to set the configuration to set the connection strings. If it is not configured, if it is, of course, I configured in a host builder configuration config service section. I think it is after DB context options, no options builder. I think builder. Then some code options builder is configured. If it is not configured, then I can set the construction string here. If it is configured, I will not set any. So it will create this function will call on configuring whenever this instance is going to create after the during the instantiation of this class. The option dot use Cosmos settings dot is dot settings. Why it is not settings dot endpoint? Oh my god, this is very slow. This one. Yeah, okay. I will pass the developing that app. I think now I will create the Cosmos DB app, Cosmos DB account. Uh, yeah, I can use the constant string. Sorry, resource group. This is account name, age, chat, Cosmos, Cosmos fine. SQL, everything is fine. I'm not changing anything. It's a free tire, everything. I'm not okay. No, not working. I'm not changing anything. Uh, we already discussed about this one encryption. We discussed tags. We create. We already create. So it will review. Then it will allow me to create. Okay, create. Okay, it will take some time. Meanwhile, I will continue this project. It will take 50 minutes. Then I will come back to that resource. Okay, settings and survey. I think service is damn slow. I don't know why it is this much. Task manager. Oh my god. Oh, I don't know why this one. It's taking too much memory. Okay, let me try. Oh my god, I already typed. Okay, then I will going to create the on model. Why it is giving okay, I will create a on model. It is the, oh my god, it's not allowing. Protected override. It is create other type. Oh my god, I already typed but it's not pasting. No, my system is very slow. Okay, then we are completed this one. College. Oh my god. I go to the programs. Okay, so it seems everything is okay. Now instead of code, I will go to the command. Consider. Yeah, it's build good, but it's not opening. Yeah, hello. I implemented a couple of classes. One is the repository class for college entity, and a helper class to fill the data, to fill the sample colleges for demo, and uh, and after that I added some dependency injection uh, to create the services. I added some services, repository and helper. See, then in the helper I write the some console up to the console to read the data and to write into the console to write to console. That's what I did. Now I will restart application. I will run the application. First, I will run the application in the development environment. Then it will fill the colleges. And it will update the departments. Uh, First call, it will programs. First call, it will fill the colleges. It will update the colleges. Then it will write the console. Then it will update the department addresses. Then items. First, I will comment this one. Comment this one. Then I will as well. Currently, it is point to the dev environment. It is point to the development environment. Then I will point to the production letter. Uh, Now I'm running this application in a development environment. Okay. Now I'm running in a it is running on a development environment. Then it is updating data. Uh, Let us see. Maybe in my development environment, I have already data. Let me delete. Let me delete again. And I'll, yeah, I will run again. I will delete again and I'll run. Okay. Then I will run again. Not this one. It is create the container and it is create the 7 items, 6 items, and there is no address. There is no address and there is no department. Then I will uh, I will update the address by using the helper class. It will fetch. It will get the college and it will update the address for each. And I will then I will run. I will build the application again. Then I will run the application. It is fetching the data and it is updating data again. Okay, then I will go to the where is did I close this one? Okay, anyway, stop. Let it be. Okay. Uh, go to the colleges and items. Go to the container. In the container, we have the document. Address is updated. No, nothing is updated. Uh, Nothing is updated. Uh, Nothing is updated. Now I will build again. I think it is not built. Did I save? Just a moment. Save. Yeah. Close. Close up. Okay. Build. Build. Okay. It should update. Uh, it is not updated. Let me check. What is the problem? Oops. Uh, debug. No, we. Yeah. Yes. Ah. Each time it is creating. No? Ah. There is an exception. That is the reason it is failing. Uh, what is this exception? Uh, yeah, I think there is some exception. I understand. There is some exception. Yeah. This is base class. Go to the helper class. Get colleges. Get all. Okay. Get all. This is the point. If it is, we are not getting the data. It seems that verify functionality is not working. Go to the repository. Get all. Uh, Something is wrong with this one. Let me check. The debug. That is the reason it's failing. Even it is not writing in console. Perfectly fine. This is great. Yeah, we have colleges. Ah, I we have colleges. That is correct. But departments is null. I think. Let me check. Even address. Address is null. This is the causing issue. I think. Uh, let me. This is failing because ID address is null. This is yeah, this is causing issue. Yeah, this is fine. Go to the address. uh, I think I write some function. I can override the some function. uh, yeah, this is fine. Apartment. No, let me check. Then it seems okay. Dot net. It's failed. Out of memory exception. It's some issue with my mission. My serious mission is some serious issue with my mission. I think memory out of memory exception. I will close as much as possible. It's fine. I think it is not working. Still, something is goes wrong. Yeah. Uh, oh, I think problem is not here. This is correct. Problem is helper class, base class. Here problem is here. Uh, hmm, yes, please take. This is fine. Then yeah, perfect. It written something. Yeah, it written the addresses. Yeah, fine. Seems working. Yeah. Now I can uh, so go to the programs. I have the address and now it is written the address as well. Uh, if you see that first it is not written the address is empty. Fine. Now I'm going to update the departments. Same document I'm updating the departments in this method. I'm trying to fetch the same document, same ID. Then I'm attaching the department, update the department. Go to the build. I don't know. I did I save it? So I'm updating the attaching. Then I will go to the emulator. Go to the address is created, department is null, and course is not created. Okay. Run. Now it is going to create the departments as well. The address is created. Now it is creating the departments. Uh, Go to the programs. What is everything is updated. Yeah, it is not writing console. No, I will uncomment this one. It will write in console as well. Go to the build. Then it will create the department departments as well. It will attach the departments to the colleges. See, this is a college. In this college, we have these many departments. This is the college. This is the address. This is the department. So department is also updated. Go to the emulator. No, this one. Um, I think it is updated. Let me try. Yeah, it is updated departments as well. Yeah, thanks. Thank you so much for attending. Thank you.